Good afternoon, students. Yes, in today's class, we'll discuss about series LCR circuit. Very important circuit for your competitive exam. Alternating current or AC through series LCR circuit. In series LCR circuit, inductor of inductance L, capacitor of capacitance C, and resistor of resistance R are connected in series with AC source. Inductor of inductance L, capacitor of capacitance C, and resistor of resistance capital R connected in series across alternating source. Instantaneous value of alternating voltage or RMS value of alternating voltage applied from AC sources V is equal to V naught sin omega t. V is equal to V naught sin omega t. Let I be the RMS value of current in the circuit. Circuit is series. L, C and R are connected in series combination. We know that in series combination, current remains same, but applied voltage will be divided across inductor, capacitor and resistor. Voltage across the inductor is VL. Voltage across the capacitor is VC. And voltage across the resistor is VR. Applied voltage VL, VC and VR ಆಗಿ ಡಿವೈಡ್ ಆಗ್ತಾ ಇದೆ. What is VL? Potential difference or voltage across inductor. What is VC? Potential difference across capacitor. And what is VR? Potential difference across resistor. VR is equal to I into R, potential difference across resistor. VL, potential difference across inductor. V is equal to I into XL, where XL is inductive reactance. VC, potential difference across capacitor. VC is equal to I into XC. XL, a portion offered by the inductor, XC, a portion offered by the capacitor, and R is a portion offered by the resistor to the flow of AC through it. What is XL? We know that XL is equal to omega into L, and XC is equal to 1 by omega into C. What is omega? Omega is equal to 2 pi F. F means frequency of alternating source. In this circuit, we are going to find the resultant voltage and impedance. Z means impedance, total opposition offered by the inductor, capacitor and resistor in series, which is called as impedance. V is resultant voltage. Impedance and resultant voltage na find out ಮಾಡಬೇಕಂದ್ರೆ okay, phasor diagram na draw ಮಾಡ್ಕೋಬೇಕು. Phasor diagram. Phasor diagram. So in resistor, what happens? Voltage across the resistor, which is in phase with the current. In inductor, what happens? Voltage across the inductor leads the current by an angle of pi by 2. In capacitor, voltage across the capacitor lags behind the current by an angle of pi by 2. Our current leads the voltage. Current leads the voltage by an angle of pi by 2. In resistor, voltage across the resistor, which is in phase with the current, phase difference between VR and I is 0. In inductor, what happens? In inductor, voltage across the inductor leads the current by an angle of pi by 2. In capacitor, current leads the voltage across the capacitor, or voltage across the capacitor lags behind the current by an angle of pi by 2. So this is the phasor diagram. VR is represented by OA. OA is equal to VR. VL is represented by OB. OB is equal to VL. And VC is represented by OC. OC is equal to VC. Here, VL and VC are opposite in phase. VL is positive, VC is negative. The resultant of VL and VC is VL minus VC. Resultant of VL and VC is VL minus VC, which is represented by OD. OD is equal to VL minus VC. Now the resultant of VL minus VC and VR is V. V means resultant voltage of VL minus VC and VR, which is represented by OE. OE is equal to V. V means resultant voltage. The resultant voltage of VL minus VC and VR is V. Now from the right angle triangle, OE square is equal to OA square plus OD square. What? OE is equal to square root of OA square plus OD square. What is OA? OA is V. V is equal to square root of, what is OA? VR. VR square plus, what is OD? VL minus VC whole square. This is the resultant voltage of VR and VL minus VC. Now applied voltage is what? RMS voltage. VRMS is equal to V naught sin omega t. But this is peak voltage. The resultant voltage is nothing but peak voltage. Peak voltage means V naught. And I naught is peak current. Peak voltage or resultant voltage of series LCR circuit is V naught is equal to root of VR square plus VL minus VC whole square. Okay. Next, we need to find impedance. Impedance means the resultant opposition or total opposition offered by the series LCR circuit is called impedance. Impedance. Impedance of the circuit. Impedance. The resultant voltage is V is equal to square root of VR square plus VL minus VC whole square. What is VR? Potential difference across resistor. VR is equal to I into R. Potential difference across inductor. VL is equal to I into XL. And potential difference across capacitor. VC is equal to I into XC. Substitute for VR, VC and VL in the above equation. V is equal to square root of, what is VR? I square R square plus VL. VL minus VC whole square. VL is I into XL minus VC I into XC whole square. V is equal to square root of I square R square plus I square into XL minus XC whole square. V is equal to square root of I square of R square plus XL minus XC whole square. Or V is equal to root of I square is I. V is equal to I into square root of R square plus XL minus XC whole square. V by I is equal to square root of R square plus XL minus XC whole square. What is V by I? V by I is equal to Z, impedance. That means impedance of the series LCR circuit. Z is equal to square root of R square plus XL minus XC whole square. XL means inductive reactance, XC means capacitive reactance, and R means opposition offered by the resistor. Current in the circuit. Current, expression for current in the circuit. I is equal to V by Z. I is equal to V by, now what is I? I means RMS value of current and V means RMS value of voltage. Root of R square plus XL minus XC whole square. Now what is the phase angle between the resultant voltage and current in the circuit? Phase angle. Phase angle between the resultant voltage and current in series LCR circuit. Phase angle. Now, the resultant voltage V makes an angle pi with the current axis or x axis, or let pi be the angle between V and I. So now from this angle, tan phi is equal to what? Tan phi is equal to opposite side AE divided by adjacent side OA. What is AE? A is equal to OD, which is equal to VL minus VC divided by OR, OA, okay. OA is equal to VR. Now, phase difference or phase angle between resultant voltage and current is tan phi is equal to VL minus VC divided by VR. If VL is greater than VC, tan phi is equal to VL minus VC. If XL greater than XC, R is equal to Z is equal to root of R square plus XL minus XC whole square. Now what is VL? VL is equal to I into XL tan phi I into XL minus what is VC? I into XC divided by VR. VR is equal to I into R. VL is equal to I into XL. VL is equal to I into XL. VC is equal to I into XC and VR is equal to I into R. Or tan phi is equal to I of XL minus XC divided by I into R. I gets cancelled. Tan phi phase angle or phase difference between the resultant voltage and current in series LCR circuit, tan phi is equal to XL minus XC divided by R. Or phi is equal to tan inverse of XL minus XC divided by R. Phase difference find out ಮಾಡ್ಬೇಕಂದ್ರೆ okay ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು. Y is equal to tan inverse of XL minus XC divided by R. Now Z is equal to impedance of the circuit. Z is equal to square root of R square plus XL minus XC whole square, and resultant voltage or peak voltage in the circuit V is equal to root of VR square plus VL minus VC whole square, and phase angle or phase difference between resultant voltage and current tan phi is equal to XL minus XC divided by R. If XL is equal to XC, then what happens? If XL is equal to XC, a portion offered by the inductor is equal to a portion offered by the capacitor, or reactance of the inductor is equal to reactance of the capacitor, then impedance becomes, if XL is equal to XC, Z is equal to root of R square XL minus XC becomes 0. This implies Z is equal to R. If XL is equal to XC, Z impedance is equal to resistance of the circuit. Series LCR circuit is equivalent to or becomes resistive circuit. If XL is equal to 0 or XC is equal to 0, if XC is equal to 0, a portion offered by the capacitor is 0, then impedance of the circuit Z is equal to root of R square plus XL square if XC is 0. Z is equal to root of R square plus XL square. Okay, then series LCR circuit becomes RL circuit. If XL is equal to 0, if XL is equal to 0, then Z is equal to square root of R square plus XC square. Z is equal to root of R square plus XC square. Yeah, impedance Z is equal to root of R square plus XC square. In this case, series LCR circuit. LCR circuit becomes RC circuit. RC circuit. So we know that average power in a series LCR circuit, P average is equal to VRMS IRMS into cos phi. What is cos phi? Cos phi is called power factor. Power factor in a series LCR circuit is given by cos phi is equal to R by Z. Cos phi is equal to R by Z. R pi is equal to cos inverse of R by Z. If XL is equal to XC, XC is equal to 0 and XL is equal to 0. Now, if XC is equal to XL, what is the phase angle between resultant voltage and current? If XC is equal to, if XC is equal to XL, okay, tan phi is equal to 0 or phi is equal to 0. In a series LCR circuit, if XL is equal to XC, then pi is 0, tan phi. Okay, tan phi is equal to 0, pi is equal to 0. If pi is equal to 0, then phase difference between current and voltage is 0. What is phi? Phi is angle made by the resultant voltage with current. Okay. If pi is equal to 0, voltage and current are in phase with each other. In phase with each other. Voltage and current. If XL greater than XC, then what happens? If XL greater than XC, if XL greater than XC, pi will be positive. Phase angle between resultant voltage and current is positive if XL greater than XC. Then if XL greater than XC, pi is positive, here voltage leads the current. Voltage leads the current. Voltage leads the current. Leads the current I by an angle pi. Voltage leads the current by an angle pi. If XC is greater than XL, if XC greater than XL, then pi is negative. If phase angle between current and voltage is negative, then voltage lags behind the current, or current leads the voltage by an angle pi. If XC greater than XL, pi will be negative. Pi is negative. Phase angle between current and voltage is negative. Then if pi is negative, voltage lags behind the current, or current leads the voltage by an angle pi. Okay. Now tan phi is equal to XL minus XC by R. If XL greater than XC, if XL greater than XC, inductive reactance is greater than capacitive reactance, then circuit series LCR circuit will be inductive. Circuit will be inductive. If XL is less than XC or XC is greater than XL, circuit will be capacitive. If XL is equal to XC, then XL is equal to XC, Z is equal to R, impedance is equal to resistance, series LCR circuit is equivalent to R becomes pure resistive circuit. Pure resistive circuit. So LCR circuit becomes capacitive, inductive and resistive depending upon frequency of alternating source. Frequency of the alternating source ಮೇಲೆ LCR inductive circuit or capacitive circuit or resistive circuit ಆಗಿ behave ಮಾಡೋದು depend ಆಗಿರುತ್ತೆ. Okay, this is about series LCR circuit. Z is equal to square root of R square plus XL minus XC whole square, and resultant voltage or peak voltage V is equal to root of VR square plus VL minus VC whole square, and phase angle between current and voltage tan pi is equal to XL minus XC by R. Okay, so this is about LCR circuit. Next, move on to electric resonance. Electric or electrical resonance. When resonance takes place in series LCR circuit, For a particular frequency of the applied AC to a series LCR circuit, current in the circuit becomes maximum and impedance of the circuit becomes minimum. For a particular frequency, of the applied AC to a series LCR circuit, current in the circuit becomes maximum and impedance of the circuit Z becomes minimum. Current becomes maximum and impedance becomes minimum. Current in series LCR circuit, I is equal to V by square root of square root of R square plus XL minus XC whole square. I is equal to V by Z. If XL is equal to XC, now what is XL? XL is inductive reactance and XC is capacitive reactance. We know that XL proportional to frequency of the alternating source and XC depends inversely on frequency of the alternating source. If F increases, XL increases. If F increases, XC decreases. At a particular frequency of the applied AC, which is F naught. At a particular frequency of the applied AC, XL is equal to XC. Inductive reactance is equal to capacitive reactance. If XL is equal to XC, current in the circuit becomes maximum and impedance of the circuit becomes minimum, okay, which is the condition for electrical resonance. XL is equal to XC. XL is equal to XC. What is XL? Omega into L. XC 1 by omega into C. Omega is equal to 2 pi into F. F naught is particular frequency applied to series LCR circuit. Now 2 pi F naught into L is equal to 1 divided by 2 pi F naught into C. F naught is equal to F naught square is equal to 1 divided by 4 pi square L into C, or F naught is equal to 1 by 2 pi into root of LC. F naught is equal to 1 by 2 pi into root LC. Okay. Or omega naught is equal to what? Or omega is equal to omega into omega. Omega L is equal to 1 by omega C. Omega into omega is equal to omega square. Omega square is equal to 1 by LC. Or omega is equal to 1 divided by root of LC. What is omega? Omega is angular resonant frequency and F naught is resonant frequency. Resonant frequency. Resonant frequency F naught depending upon L and C. Inductance of the inductor and capacitance of the capacitor ಮೇಲೆ F naught depend ಆಗಿದೆ. F naught is independent of resistance of the circuit or resistance of the resistor. F naught is independent of R. F naught is equal to 1 by 2 pi into root of LC, resonant frequency. At resonance, what happens? At resonance, condition for resonance or at resonance. At resonance, XL is equal to XC. XL is equal to XC. If XL is equal to XC, then impedance becomes Z is equal to root of R square plus XL minus XC whole square. If XL is equal to XC, Z is equal to root of R square, square and root gets cancelled, Z is equal to R. Impedance is equal to resistance of the resistor. At resonance, XL is equal to XC and Z is equal to R. Z becomes minimum. Z becomes minimum. Impedance is decreasing, but current in the circuit increases. Z is equal to R. Then expression for current, I is equal to V by Z. Z is equal to R. Now, what is the phase difference between resultant voltage and current? If Z is equal to R, series LCR circuit behaves like a purely resistive circuit. Behaves like a purely resistive circuit. If LCR becomes purely resistive circuit, what is the phase difference between current and voltage is? Phase difference between current and voltage is 0 degree. Current and voltage are in phase with each other. Current and voltage are in phase with each other. Now, what is the value of power factor? Cos phi. Cos phi is equal to 1. Cos phi is equal to 1. Phase difference between current and voltage is 0 degree. And also, resonant frequency F naught is independent of the resistance, independent of the resistance of the circuit. Means F naught is independent of R. Independent of R. F naught R ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರೋದಿಲ್ಲ. Because F naught is equal to 1 divided by 2 pi into root LC. F naught depends on inductance of the inductor and capacitance of capacitor. So F naught is independent of resistance R. As the value of R increases, value of R increases, sharpness of the curve decreases. If the value of R decreases, sharpness of the curve or resonance curve increases. So sharpness of the resonance curve depends inversely on sharpness of the resonance curve depends inversely on resistance. Sharpness of the resonance curve depends inversely on resistance R. As R increases, sharpness decreases. Okay. This is about electrical resonance. When XL is equal to XC, current in the circuit becomes maximum. Impedance of the circuit is minimum. Series LCR circuit behaves like a purely resistive circuit, and expression for resonant frequency F naught is equal to 1 by 2 pi into root LC. Angular resonant frequency omega naught is equal to 1 by root of LC. So this is about electrical resonance. So moving on to next concept, transformer. Very important for your competitive. Transformer. Transformer is a device which works on the principle of mutual induction. Mutual induction or mutual inductance. So what is the use of the transformer? It is a device used to increase or decrease voltage in AC circuits. It is a device used to increase or decrease voltage in AC circuits. Transformer. Transformer consists of two coils. It consists of two coils called primary and secondary. Primary coil, secondary coil. Primary coil is connected to alternating source of voltage V or EMF E, and output is taken across the secondary coil. Output is taken across the secondary coil. Input coil means primary coil and output coil means secondary coil. Let NP and NS be the number of turns in primary and secondary. Now what is NP? NP means number of turns in primary coil, and NS means number of turns in the secondary coil. Number of turns in secondary coil. What is VP? VP and VS are the voltages in primary and secondary coil. VP means voltage in the primary coil, input voltage. VS means voltage or voltage in the secondary coil or output voltage. VP, voltage in the primary coil. VS is voltage in the secondary coil or voltage across the secondary coil. So what is voltage ratio? As number of turns in the coil increases, voltage also increases. V is proportional to N or N is proportional to V. Voltage ratio. That is Vs by Vp is equal to Ns by Np. The ratio of the voltage across secondary coil to the primary coil is equal to ratio of the number of turns in the secondary coil to the primary coil. Vs by Vp is equal to Ns by Np. Voltage ratio. Ip, let Ip and Is are the currents in primary and secondary. Let Ip be the current in the primary coil, Is be the current in the secondary coil. Now what is current ratio? current ratio. Current ratio is Vs by Vp is equal to Ns by Np is equal to Ip divided by Is. Vs by Vp is equal to Ns by Np is equal to Ip by Is. Okay, this is current ratio. This is what? Voltage ratio. In transformer, there are two types, step-up transformer and step-down transformer. What is step-up transformer? Step-up transformer. Voltage across the secondary coil is greater than primary coil, then the transformer is called as secondary. Okay, voltage primary ginta ಜಾಸ್ತಿ ಇದ್ರೆ the transformer is called as step-up transformer. If voltage across the secondary coil is less than the primary coil, then the transformer is called step-down transformer. Step-down transformer. Step-up transformer. Step-up. Voltage across secondary coil is greater than primary coil. Now, what is current ratio? Current ratio is what? Current ratio Vs by Vp is equal to Ns by Np is equal to Ip by Is. If Vs greater than Vp, Ns greater than Np, Ns greater than Np, Ip is greater than Is, or Is is less than Ip. Voltage across secondary coil is greater than the primary coil, then the transformer is called step-up transformer. For step-up transformer condition is Ns greater than Np, Vs greater than Vp, and Is less than Ip. Step-down transformer. Voltage across the secondary coil is greater than the primary coil, then the transformer is called step-up. If voltage across secondary is less than the primary, then the transformer is called step-down transformer. For step-down transformer, Vs less than Vp, Ns less than Np, and Is greater than Ip. So this is what types of transformer, step-down and step-up. Efficiency of a transformer. Efficiency of a transformer denoted by eta. Efficiency of a transformer, eta is equal to output power divided by input power. Eta is equal to output power or power output divided by power input. Input means primary coil, output means secondary coil. Eta is equal to P out divided by P in. Eta is equal to P output by P input. Percentage efficiency, eta in percentage is equal to eta is equal to percentage eta is equal to P output divided by P input into 100. What is P output? Output power. Power means product of voltage and current. Output power means secondary coil, product of the current and voltage in the secondary coil. P output is equal to Vs into Is. P input is equal to Vp into Ip. Current in the primary coil is Ip. Power in the primary coil is Vp into Ip. Power in the secondary coil, P output is equal to Vs into Is. So, eta in percentage Vs into Is divided by Vp into Ip 100. For an ideal transformer, there is no loss of energy. If transformer is assumed to be 100% efficiency or ideal transformer, for ideal transformer, for ideal transformer, for ideal transformer, power output is equal to power input. Output power is equal to input power. Power across the secondary coil is equal to power across the primary coil. The transformer is assumed to be 100% efficiency or 100% efficient. For an ideal transformer, P output is equal to P input. P output means Vs, Is, P input means Vp into Ip. For an ideal transformer, efficiency is 100%. Efficiency is 100%. So, this is about transformer. Percentage eta is equal to power output by power input into 100. For an ideal transformer, output power is equal to input power or efficiency is equal to 100%. Current ratio and voltage ratio. Voltage ratio is Vs by Vp is equal to Ns by Np. Current ratio Ip divided by Is. So, this completes the chapter alternating current. Next, we'll solve some problems based on the concepts which are explained yesterday and today's class. First problem. Peak current, peak value of current in a circuit is, peak current means I0. Peak current in a circuit is 28 ampere. So, what is the RMS value of current? Peak current in the circuit is 28 amps and RMS value of current in the circuit. We know that the relation between IRMS and I0. IRMS is equal to I0 by root 2. I0 is 28 ampere. Root 2, what is the value of root 2? 1.414. IRMS is nearly equal to 20 amps. RMS value of current. Similarly, second problem, if peak voltage in AC circuit is 100 volts, what is RMS voltage? The relation between VRMS and V0, VRMS is equal to V0 by root 2. VRMS is equal to 100 divided by root 2, 1.414, 100 by 1.414, nearly 71 volts. Relation between I naught and IRMS, V naught and VRMS. Third problem. The reactance of a coil means inductor. Now reactance of a coil, XL, when VRMS is 220 volts and frequency 50 Hertz. The reactance of a coil is given 50 ohm. The reactance of a coil is 50 ohm. Frequency of AC source is 50 Hertz. Inductance of the coil is inductance of the inductor is L. We know the relation between inductor reactance and frequency of AC source. XL is equal to 2 pi F into L. L is equal to XL divided by 2 pi into F. XL is 50 ohm, 2 into pi into what is frequency 50. L is equal to 1 by 2 pi N3. RL is equal to 1 divided by 2 into value of pi 3.14. L is equal to 0.16 N3. L is 0.16 N3. Problem number 4. If R is equal to 6 ohm, inductive reactance XL is equal to 12 ohm and capacitive reactance XC is equal to 4 ohm. Impedance of the series LCR circuit is, if R is 6 ohm, XL is 12 ohm and XC is 4 ohm. Impedance of the circuit Z is equal to square root of R square plus XL minus XC whole square. Z is equal to root of R square. R is 36 plus XL 4 XC. XL is 12, XC is 4 whole square. Z is equal to root of 36 8 whole square root of 36 plus 64 root of 100, which is equal to 10 ohms. Z is equal to 10 ohms. Impedance of the circuit. Next question. If voltage across inductor VL is 50 volts, voltage across capacitor VC is 10 volts, and voltage across a resistor VR is equal to 30 volts. What is the peak voltage in series LCR circuit? Peak voltage or resultant voltage? Peak voltage or resultant voltage in a series LCR circuit, V naught is equal to root of VR square plus VL minus VC whole square. V naught is equal to square root of VR is 30 square, VL is 50 minus VC is 10 whole square. V naught is equal to square root of 30 square plus 40 square. V naught is equal to 50 volts. Yes. Chalo stop.